Hey everyone, and welcome back to the channel. Today, we're diving deep into a topic that is absolutely essential for anyone looking to take their application from a local project to a global sensation: web servers. You've built an amazing app on your computer, but how do you get it out there for the world to see and use? That's where web servers come in. Think of a web server as the home for your application on the internet. It's a powerful computer that's always on, always connected, and its main job is to listen for requests from users' browsers and serve them your application as files. When someone types your website's address into their browser, they're really just sending a request to your server. The server then finds the right files: HTML, CSS, JavaScript. Imageson sends them back to the user's browser, which then assembles and displays the web page. It's the magic that makes the web work. So, what exactly is a web server? At its core, it's a combination of hardware and software. The hardware is the physical machine, a computer itself, with its CPU, RAM, and storage. The software is what does the heavy lifting. This includes the operating system, like Linux or Windows Server. And the web server software itself, such as Apache, NGIN, X, or Microsoft's IIS. These software packages are designed to handle incoming HTTP requests efficiently and securely. They manage connections, process requests, and deliver content. Without this specialized software, a regular computer wouldn't know how to respond to a browser's request. It's the brain of the operation, turning a simple machine into a powerful hub for your online presence. So when we talk about setting up a server, we're really talking about configuring this hardware and software stack to work together perfectly. Now, let's talk about the different types of hosting you'll encounter. The first and most common for beginners is shared hosting. Imagine living in a large apartment building. You have your own apartment, but you share the building's resources like the plumbing, electricity, and the main entrance with all the other residents. Shared hosting is similar. Your website lives on a server alongside hundreds, sometimes thousands, of other websites. You all share the server's CPU, RAM, and bandwidth. The biggest advantage here is cost. It's incredibly cheap, making it a great starting point for personal blogs, small portfolios, or low-traffic sites. However, the downside is performance. If another website on your shared server suddenly gets a huge spike in traffic, we call this the noisy neighbor. Affectit can slow down your site too, since you're all competing for the same limited resources. Moving up the ladder, we have VPS hosting, which stands for Virtual Private Server. This is like owning a condo in that same apartment building. You still share the physical building with others, but you have your own dedicated, walled-off space with your own resources. A VPS uses virtualization technology to partition a single physical server into multiple virtual servers. Each VPS runs its own operating system and is allocated a specific amount of CPU, RAM, and storage that is exclusively yours. This gives you much more control and better performance than shared hosting. You can install your own software and configure the server environment exactly how you want it. It's a fantastic middle ground for growing businesses, e-commerce stores, and applications that need more power and flexibility than shared hosting can provide, but without the cost of a dedicated machine. Next up is dedicated hosting. This is the equivalent of owning a standalone house. You get an entire physical server all to yourself. No sharing, no noisy neighbors, all the CPU, all the RAM, all the storage. It's 100% dedicated to your application. This offers the highest level of performance, security, and control. You have complete root access, meaning you can customize everything from the operating system to the hardware configuration. Dedicated hosting is ideal for high-traffic websites, large-scale enterprise applications, and any project where performance and security are absolutely critical. Of course, with great power comes great responsibility and a higher price tag. You're also typically responsible for managing the server yourself, unless you opt for a managed dedicated hosting plan. Finally, we have the modern champion, cloud hosting. Cloud hosting is a bit different. Instead of renting a single physical or virtual server, your application is hosted on a vast, interconnected network of servers. Think of it like a utility, like electricity. You just plug in and use as much as you need, and you only pay for what you consume. Major providers like Amazon Web Services, AWS, Google Cloud Platform, GCP, and Microsoft Azure offer this. The key benefits are scalability and flexibility. If your app suddenly goes viral, the cloud can automatically allocate more resources to handle the traffic spike. If traffic dies down, it scales back down, saving you money. This elasticity is incredibly powerful. It combines the control of a VPS with unparalleled scalability. But it can have a steeper learning curve and unpredictable costs if you're not careful with your resource management. Okay, so you've chosen a hosting type. What's next? Configuration. This is where you roll up your sleeves and set up the server environment. Let's start with the basics. First, you'll need to gain access to your server, usually through something called SSH or Secure Shell. This gives you a command line interface to your server, allowing you to run commands and manage files securely from your own computer. Once you're in, one of the first things you'll do is update your System S software packages to make sure you have the latest security patches. Then, you'll install the core components of your web stack. A very popular one is the LAMP stack, which stands for Linux, Apache, MySQL, and PHP. Linux is the operating system. Apache is the web server software. MySQL is the database. And PHP is the programming language. You'll install each of these components and configure them to work together. Let's break down that configuration a bit more. For Apache or Nginx, you'll need to create a virtual host file. This file tells the web server how to handle requests for your specific domain name. It specifies where your website S files are located. This is called the document routine, sets up any special rules, like how to handle errors or redirect URL. Next is the database. If your application needs to store data, like user accounts or blog posts, you'll need a database like MySQL or you'll create a database and a database user, and you'll grant that user the necessary permissions to read and write to the database. It's super important to set a strong, unique password for your database user to keep your data safe. This initial setup is crucial for a stable and secure foundation for your application. Security is not an afterthought. It's a fundamental part of server configuration. You're putting your application on the public internet, which unfortunately means it's a target. The first line of defense is a firewall. A firewall, like UFW, Uncomplicated Firewall on Linux, allows you to control which network ports are open to the world. You should only open the ports that are absolutely necessary. For a standard website, that's usually port 84 HTTP and port 443 for HTTPs. Everything else should be closed. Speaking of HTTPS, setting up an SSL certificate is non-negotiable today. SSL encrypts the data transferred between your server and the user's browser, protecting sensitive information like passwords and credit card numbers. Services like Let's Encrypt offer free SSL certificates, so there's really no excuse not to use HTTPS. It not only secures your site, but also improves user trust and can even give you a small SEO boost. Now, for the exciting part, deployment. Deployment is the process of getting your application's code from your development machine onto the live server. The simplest method is using SFTP, or Secure File Transfer Protocol. You can use a client like FileZilla or CyberDuck to connect to your server and manually drag and drop your files into the correct directory or document root. While this works, it can be slow and error-prone for larger projects. A more professional and efficient method is using Git, a version control system. You can set up a Git repository on your server. Then, when you want to deploy, you just push your latest code changes from your local machine to the server. You can even set up scripts that automatically run after a push to do things like install dependencies or restart your application. This creates a much smoother and more reliable workflow. For more complex applications, you'll want to look into automated deployment tools. This is where CI/CD comes in. CI/CD stands for Continuous Integration and Continuous Deployment. Tools like Jenkins, GitHub Actions, or GitHub CI can automate your entire deployment pipeline. Here's how it works. When you push new code to your repository, it automatically triggers a series of steps. First, it might run automated tests to make sure the new code didn't break anything. If the tests pass, it will then build your application and deploy it to the server, all without any manual intervention. This process is faster, more reliable, and allows you to release updates much more frequently. Setting up a CI/CD pipeline is a key practice in modern software development and is essential for teams that want to move quickly and confidently. It takes the stress and risk out of deployments. So, you've deployed your app, and it's live. Your job isn't over yet. Now comes monitoring and maintenance. You need to keep an eye on your server to make sure everything is running smoothly. This includes monitoring resource usage like CPU, RAM, and disk space. If any of these are consistently high, it might be a sign that you need to upgrade your hosting plan. You should also set up logging. Your web server and application generate logs that record errors, security events, and other important information. Regularly reviewing these logs can help you spot problems before they become major issues. There are great tools, both free and paid, that can help you aggregate and analyze these logs. Proactive monitoring is the key to maintaining a healthy and performant application for your users. Thanks for sticking with me through this deep dive into web servers. If you found this helpful, be sure to hit that like button and subscribe for more content. See you in the next one!